Okay, everybody, welcome to day 2 of Lightning Talks. We have a jam-packed schedule of very exciting talks. So we are going to get started with John from Google.
Thank you. That's the last time I'm going to say My name is John Trescott-Reese, and I'm the world's most fantastic public speaker. I work at a company whose name, if spelled backwards, be pronounced El Goog. So this job that we do is very intense, very emotionally draining, and people tend to react to it by sometimes becoming superstitious. There become parts of our systems that we are afraid to touch. We don't know what will happen, so we don't touch them. And that the message of this talk is, I realize it's hard to fix that, but be aware of it, give it a name, consider fixing it, because it's a bigger deal than you think. And I'm referring to this phenomenon as haunted graveyards. Also, the slide I have here is so tiny that I'm going to look at the screen periodically. So there's a bunch of examples. You will probably have examples from your own experience. There is the race condition that you usually win, so you just get used to periodically running the tool twice. There is the design problem where you're like, well, this should go in system A, but the owner for system A no longer works here, so let's put it in this worst place, system B, and our system will slowly become more incomprehensible over time. Letting an API mutate because the deprecation process for an API is hard. You start to violate the principles Tanya was talking about in the plenary session this morning of having APIs that are natural and match your intuitions. They start to become weird because you're avoiding pitfalls that only you understand, or only you think you don't understand. And legacy systems that continue lurching along, carrying critical business traffic, even though nobody still knows how they work. So this is one of my favorites. There is a file somewhere in the source tree of a company known to me. Title of this file is ZOMG do not create, and then the name of the system is name of the type of system and the dash and the zone that it ran in. We use a scheme for zones where it's 2 letters long, so you can have at most 676 zones. And we reuse zone names over time. And this particular cell was turned down using dark magic that they fear might spring back into life if one were to recreate a cell with that name. To their credit, they wrote it down. Most people don't write this down. So for some SREs, this is actually a change in philosophy. Many of us think that our job is to avoid risk at all costs. But that often translates into let's avoid short-term risk by not doing the thing we know might be dangerous. But having parts of your system that you are afraid to touch that is a risk. That's a bigger risk, actually. It's just a longer-term risk. So you need to fix that. And the way I recommend that you fix that is one of the key SRE principles is you have an error budget. So you want to be up 99.9% of the time or whatever. That means you have 0.1% of the time that's a budget that you can do a little bit of riskier experimentation with, such as trying to, exercise the graveyard. Now, one caution is that there is a seemingly opposing principle called Chesterton's fence, which you should also be aware of, which is, hey, if there's something out there that I don't understand, and I just want to delete it so I don't have to learn what it does, that's itself a pretty risky thing to do. It's better to figure out what it did, figure out that you hate it, figure out that there's no longer any need for it, and make it go away. And I see these two principles as both sort of like a 1-2 punch that basically just says you need to understand your system. There's no shortcuts. This concludes my talk. Thank you.
And next up, we have Raja from the Home Depot.
Thank you. So my name is Raja Selvaraj, and I'm a senior manager at HomeDepot.com. I lead the reliability engineering organizations for the browse and search areas of HomeDepot.com. If you did not know already, HomeDepot.com runs on public cloud. So we run on Google Cloud Platform. There were a couple of talks in GCP Next about how we migrated from a monolithic architecture to more of a microservice-based architecture, and how we transformed our reliability in those talks. So if you're interested, you can listen to those. Now that I'm done with the promotions, I have to talk about Home Depot in general. If you do not know already, Home Depot is the largest home improvement retailer in the world, and it's a Fortune 50 company. The reason why I'm saying that is because we have got our own challenges, and technology plays a very key role in delivering our interconnected retail strategy, and whose focus is to deliver seamless customer experience across our stores and also on our website and mobile properties. So the reason I've stated that again is because reliability plays a key role, and we take that as extremely serious, because we have to maintain reliability across all our services in both the stores, in our back channel applications, and also on our website and mobile apps. So having stated that, why measuring reliability is important, I'm pretty sure you all know, but I want to reiterate this. And you all might have experienced this in your careers at some point of time. Let's say you're troubleshooting a production issue, or you're in the middle of solving a complex technical challenge, and you've made a breakthrough by figuring out that a service that you're dependent on is either throwing some errors or it's slowing down, and you call somebody who's handling that service, or you ping them on Slack, and 9 times out of 10 you're going to hear, hey, my service is running fine, everything is peachy, right? I hope you all have heard that. If not, then maybe I'm the only one, but that's a common occurrence. And most of the times that you hear that is because we don't have a standardized way to measure reliability and monitor and report it. The reason why I'm mentioning that is because in Home Depot we decided to use a set of metrics to standardize the way we measure reliability, and that's extremely useful in a large company, in a large enterprise like Home Depot, where you have multiple teams. Different teams operating on different technologies, different teams operating on different cloud providers, a whole array of systems and complexities and legacy technologies involved. So when you standardize the metrics that you use, those conversations become much more easier. And the other thing that is very important is, like, one common pattern that you might have seen in this entire conference is, if you don't measure, you don't improve. In my opinion, measuring is the first step in establishing that feedback loop so that you can continue to improve and continue to measure. So we use an acronym called VALET to standardize our measurement of reliability. The first one is volume. So basically how many requests your service is handling at that particular moment in time. So, requests per second, transactions per second, reads per second, writes per second, errors per second. I'm pretty sure you all know what I'm talking about. This is very critical, especially if you're running a service that has got limited capacity. I'm pretty sure we all have experienced this, like, a network link getting saturated or a database getting slowed down because of exceeding the number of writes that it can handle. A service not being able to create file handles because it is reaching the file handle limit. All these kind of things, you need to monitor this. The next one is availability. So basically how available your service is. And because I'm part of HomeDepot.com, one important thing that we measure, because it's a publicly available service, we measure availability at the edge of our infrastructure, and also we measure it at the customer's site, so that we see, so that we can see what the customer is experiencing. So that's pretty critical, and it gives you a perspective about what the customer is seeing. Even though you might think that your service is running fine, the customer might be having problems, either because of internet latency or because of some problems at their ISP. So critical to measure. The third one is latency. How long your service is taking to respond. The most important thing in latency is measuring your service at different percentiles, 50th percentile, 90th percentile, 95th, 99th. If you can go above 99th percentile, you can. And you should, especially if your service is handling a lot of volume. 90th percentile might not do justice, because if you're handling 100,000 requests a second, 90th percentile is only 90,000 requests, or what, you get the point. Errors. So the basic errors, since I'm managing HTTP traffic, we usually do 4xx, 5xx errors, but of course it does not stop you from just measuring 4xx, 5xx errors. You can measure all kinds of errors, how many disk errors you're having, or socket timeouts, connection timeouts. You can keep on going. The last one is tickets. So basically measure how many production incidents you're having. The main reason why you do that is because this will also allow you to determine your MTTD and also your MTTR. And especially if you are in leadership roles, this becomes pretty critical, because this is how you can measure how well your teams are doing, especially if your team's on-call responsibilities. And that's it. Thank you. One last note. We are hiring across multiple locations in the US. So if you're interested, please let us know. Thank you.
And now we have Cezar from Microsoft.
So hi everybody, I'm going to talk a little bit about the lessons learned that we have during our transition into SRE team. So we don't want to reinvent the wheel. So you look for what Google had and the graphic that they had create, and we definitely want to be in that elite box, but in reality, we are like more that. Have like a lot of people with experience with service engineering, and also a few folks like me that has like a lot of experience in Microsoft as a software engineer. But we were trying to together go in that direction, right, for the elite box. So we grouped the lessons learned that are going to show in that three groups. That is how, or three roles, is how we organize our team. But we understand that a lot of companies, tech lead and SRE manager, basically the same role, or they do the same things, but can help for you guys understand what the lessons learned we had. So let's talk about first SRE manager. So as a people manager, the SRE manager needs to help the team to grow, right, and to develop the skills that they need to get in the desired black box daily team. But although we are basically talking about two different skills, software engineer and service engineer, the reality, each individual is at a different level of their career in their skills. Though there is no really a good recipe that they can follow and say that everybody here is going to follow that recipe and going to get in the black box. So the SRE manager need to look for each of the individual in their team and see how they can help them to get there. But most important, and it's really work for everybody in our team, it is pair up with mentors. So we get someone that has like more experience in service engineering and pair up with someone, for example, that is more code engineering or coding skills. So it's sometimes has their own challenge. For example, sometimes we have like a senior service engineer, and the only person that have available to pair up someone that is a more junior that has experience like with the software engineering skills. And sometimes for some people can be weird to like learn with someone that is younger than him, with less career than him. But it's worked pretty well for us, and it's helped mainly to balance actually the knowledge of the team and make everybody kind of growth in the same direction. And was very successful for us. Another thing that we're learning is that during that transition, some people going to realize that, you know what, I don't want to be SRE. Or because they don't have the skills, or because they love what they are doing. And what we learned is that we should actually encourage people and celebrate that. It's okay to move on. And it has a funny story that happened in our team. I have joined like for a few months in that team, and that is someone that I like to work with. And then one day I receive a mail, okay, let's celebrate that guy X is move on. And I say, oh, I think I was the only guy that liked that guy, right? People want to celebrate. Maybe having received this email as well. And I came to my manager and I say, yeah, it looks like weird, right? We are celebrate that the guy is actually moving on. I mean, give the impression that people don't like him. And say, no, we are celebrate that he had like the new step on his career. He loves network, actually find like a very nice work to work inside Microsoft yet, but with network, so we celebrate that. And it's what have been done so far. We really celebrate and encourage people, not just people that is moving to the elite box and doing the transformation to SRE, but also people that understand that they want to have like maybe a different career path. So let's talk a little bit about the tech lead. So the tech lead has like a very important role to help so the members of the team to develop the skills in both sides to get the elite box as a service engineer or also as like the ones that came from the software engineer, right? So it's very important that doesn't matter what you used to do before as a service engineer or a software engineer, but you need now have time to spend with your team and need to make space in your agenda and your week to spend time with the members of the team, maybe like debug an incident and try to understand what's happened. So in that way, we can help them to develop. In our team, for example, we decide that the tech lead, and in this case, I was the tech lead, we would help them pairing programming to help them with the software, and we did that. So in that way, we could even measure how people were developing and developing their skills. Another thing is managed expectation. A lot of things is happening at the same time, right? We need to transition from SAE to SRE. We also need to understand what's going to be our on-call rotation and have the pressure like when you're going to do our first code contribution, what's going to be the velocity of the team, and so on. So as a tech lead, we need to kind of help the team block that and manage the expectation mainly from our managers. And we should do that not just saying, okay, oh, I don't know what's going to happen. Oh, it's been pretty hard. Or, oh, the team is having some difficulties, right? In our case, what happened, it is we try to use data. So we had a plan. Okay, we need to do our first contributions. Okay, so how are we going to do it? Where are we going to get there? What steps are we going to have? And we could then back to the team and then also manage the velocity, right, and expectations, because it doesn't matter if you were service engineer or software engineer, you are learning new things. So now we cannot have the same velocity that we had before. But when you use the data to show it, was pretty good to help the support, and we get all the support that you need from our leadership to deliver what we need. And most important, create the culture. In our team, since the beginning, we looked at and defined what would be our culture. We want to use Kanban to control our backlog. We're going to also do TDD, and we're going to have continuous integration, continuous deployment. We're going to do this type of on-call rotation. And we were not perfect, of course, right? We failed in the first times, and we still learning for many months and still learning until today. But most important, we defined the North Star for our team. So everyone in the team understand exactly what the culture that would have, where we would be, and then it's easy for them also to understand what the transition that they need to do and how far we are or not from that. And then finally, engineer. So with all of those things happening, we have a lot of things to learn, right? And it's important for us, so start to using the tools that we have available. Some companies have some tools available, like, for example, internal tools. Others like to read books. That is my case. Or they like to use online tools. Use the tool that is make more sense for you, but learn. And there is an interesting story as well that happened in our team about tools, because I love to read books, and I read books all the time. But not necessarily, I think it's for everybody, right? So in one discussion of our team, we talk about some topic and say, you know what, I read like a very good book, that, I mean, you guys should read it. One engineer in the team gets very excited to go there, talk with the admin, got the books, everybody now had the book. Some few weeks later, as a month, people start to ask a question. I reply and answer the question, of course, but say, do you know what? There is a chapter in that book that talk about it. You should read it. And then start to do that all the time. One day in the lunch, even if I ask about Seahawks, the guys would tell me, read the book, right? I noticed that not everybody liked to read the books and decided on learning reading a book. But also it was important for the team that they understood that they need to do some effort to learn, right? We're not going to do that transition and just doing our work. We need to go there and also find the tools that make sense for us, but also growth of learning. And be open to work differently. If I was a SaaS engineer, now my work changed. If I was software engineer, my work also changed. Now it's a SRE. So the way that we would work is not more the same. The things changed, and we should be open for that. Another example that we had in our team, as we had decided that we would do pair programming, we as a geek, we have like a very sentimental relationship with our keyboard, right? We don't like people touching our keyboard. Sometimes we bring our keyboard from home. And one of the guys of our team was like that, right? So when you need to pair, we could notice that his heart was feeling really bad because he doesn't want to share. But he has like an open mind. So he was like working with us, and we still do pair programming sessions with him. And because he also see the benefit of that, right? So final thoughts. First, create your culture. I described a little bit the culture that worked for us. You need to figure out what the culture that worked for your team, for your company, right? And start small. The steps that I described here was done in one of the SRE teams that we have in Azure. And even our team being around like 12 people, we start with like 4 people. And then when you have like that for a few months later, when that people had to understand what the culture they want to have, you then add 2 more new hires, and then so on. And today we have like 8 people working in the same group. And what's pretty good for us because it helped us that even the other guys could contribute and also make that culture to be spread. So I'm Cezar G. You can talk to me if you want to in the booth of Microsoft. And also if you guys want to remember, you're going to have like a Surface at 445. Thank you.
And now we have Lei from Shopify.
Hi, my name is Lei, and I'm a production engineer at Shopify, specifically on the developer acceleration team. So my team's job is to make developing at Shopify the best experience possible, and we do this mainly by writing really cool tools. And I'm going to be talking about one of those today, and if you couldn't guess by the title, it's about our deploy tool. So our deploy tool is called Schmidt, and it's open source, so you can find it at this link here. When I joined Shopify over a year ago, this is kind of what our pipeline looked like. A developer would merge their code into master, which would kick off a container build and a CI run, which is both orchestrated by Schmidt. And then Schmidt would then complete those 2 tasks, and a deploy button would appear in the Schmidt UI, and the developer would again click to deploy their code. And this process would take about 4 to 5 minutes to ship all this new code into production. And so this process at the very end took about 4 to 5 minutes, and with this setup, we were able to deploy around 30 to 40 times per day on average. But our team, wanting to automate everything, we set our sights on automating the click to deploy step. But we might ask, we're already shipping a lot, why even bother auto-deploying? Well, we had 2 main reasons for this. The first being deploy logjam. This happened when at peak hours, such as right after lunch, we'd get a huge amount of commits being merged at the same time. And this was a problem in the cases where something went wrong in production. It was way harder to pinpoint which commit was really causing the issue. So with Autodeploy, we would be able to limit the amount of commits that came in every deploy. The other main reason was unshipped changes. So either because someone forgot to ship their changes, or because they assumed someone else would click the deploy button, we would have issues where the developer who shipped their code or who'd merged the code was no longer there when the change was actually deployed, and they're not there to take responsibility for it. So with that in mind, we updated our pipeline. You still have the developer merge their code into master, kick off a container build and a CI run, and then Schmidt now takes care of deploying the code when it's ready. And this happens at a configurable batch size at a configurable rate. And again, it all goes into production. So this is really fun and had a few impacts on our culture. The first being high expectations on our team, because developers are expected to stay around, so our system has to be fast and reliable. The second is trust. So we put a lot of trust in our developers to ship production-ready code. And finally, fearlessness. So this comes back to the issue of unshipped changes. Maybe some of those developers were scared to be the one to click deploy that deploys the batch of code, but here you are owning your code when you hit the merge button. So you might be wondering if hitting merge is the final step in interacting with our deploy system. How do people know when their changes have been shipped? That's where another one of our tools comes in handy, our chat ops bot called Spy. So Spy, when you merge your code, Spy will send you a message that says, hey, you merged your commit, it's going to be scheduled to deploy in the next few minutes. When the CI run and the container build are complete, you'll get another message that says, hey, like the deploy is starting, just so you know. And finally, when the deploy is complete, you'll get one final message and a gentle reminder to say, hey, go verify your changes. And as you can see by timestamps, this one took around 5 minutes. So far, I've just been talking about cases where everything is fine and dandy, but what if something goes wrong? Well, in the interest of keeping it as easy as possible, we have 5 steps. The first is to lock deploys. This prevents any new changes from kind of piling up, and we don't want to interfere with the rollback process, because that's the next step, is rolling back your commits, and this is just one red button in the Shipit UI. Rolling back should have gotten us back into a good state, so the third step is to verify this. Then we can revert our commit so that our master branch is clean again. And then unlock deploys so we can start shipping again. One issue with this previous setup is that when deploys are locked, that's really great for the engineers who are trying to solve an issue, but it really sucks for everyone else who's just trying to commit their code. Because when the deploys are locked, you can't really add your commits into master yet. So that's where we innovated again, and we added a merge queue. So a merge queue allows us to, instead of clicking to merge your commit into master, you can enqueue your merge. And when the pipeline is ready, Shipit will merge your merge your commit into master. And don't worry, we have a timeout. So if your commit is in the merge pipeline or the merge queue for more than 20 minutes, before it is merged into master, you get another message from Spy asking you to confirm that you're still around. So this is a pretty awesome system that we've built already, but we're always looking for more to improve. The first thing being speed. The dream would be one change per deploy, but we're not quite there yet. So we've started instrumenting our pipeline to see where we can improve. The second thing is testability. So we have around 4 nines of testability, but when you have thousands of tests, a few flaky tests can still cause a lot of lost human and compute time. The third thing would be auto rollback. So that's kind of the next logical step after auto deploy, but we'll have to kind of look into which metrics are best for us to look at in terms of auto rollback. Another wish list item is canaries, so being able to roll out on a small set of machines. That would really help with upgrades. And finally, we're also working on another open source project to help us deploy with Shipit to Kubernetes, and you can check it out there. Thank you for listening, and if you have any other questions, we're out in a booth in the corner.
And now we have Tom from IBM.
Cool, thanks. So thanks everyone for showing up this lightning talk session. The turnout's awesome. My talk is entitled SR Security. It was originally planned as a 40-minute session, and it got accepted as a 10-minute one. So if you're interested in the full version of the presentation, it will be available for download from my brain just outside the door right after this session. As the title infers, this is sort of a talk discussing the integration or how you can intertwine some SRE concepts into your security requirements. So first I'm going to start out by talking about what is a security engineer. So a security engineer needs to be a software engineer or a computer scientist, but most importantly has to be a developer. It also is important for a security engineer to have some security training and experience, and that might seem like it goes without saying, but you'd be surprised that in a lot of cases there's a lot of skills lacking there. So training and experience in the field of security is very, very important for this role. And finally, taken shamelessly from Google's SRE Bible, it's important for them to have a belief in and an aptitude for developing software as a solution. Developing software systems as a solution to complex problems. So what if I told you that it's worth hiring a team of these people? You'd probably come back to me and tell me that, my sysadmins and my operators are, they're a lot cheaper, and if I've got a security focal that's organizing this work for me. You'd also probably get back to me and tell me, I don't have time. My company doesn't have time. My engineers don't have time to be doing this stuff. And last but not least, you'd tell me that your engineers don't really want to. They're not really interested in applying patches and running security scans and that sort of thing. I know when I started in the security role, that wasn't very interesting to me. But it turned out that actually turned out to be one of my greatest strengths in this role. I didn't want to be doing those things, so I found better ways to solve the problem. Found ways to develop common solutions and really automate the processes. And that turned out to be a strength. And I think it's a strength. It's actually a benefit if you assign people to this role that don't want to do those mundane tasks, because they'll find better ways to do it. Security is not a checkbox. When you start to develop an application, you might develop something like Hello World, and then you might say, I want my Hello World application to be secure. I think we can all agree that's a pretty easy thing to do. Now, a couple of pull requests and a few minor tweaks later, and you've got yourself an application that's being used around the world by millions of people and storing confidential data for very important companies. I think we'll agree again that the compliance check you did on that Hello World application is not going to apply at this point. So security and compliance requirements are ongoing. And again, sort of stolen shamelessly, a lot of these security tasks are toil, right? So they're manual, they're repetitive, they don't have a lot of enduring value, not very much fun, and they scale linearly at best. So I'm going to go through a quick example. This is a common example, security requirement of monitoring and logging. So your developers might come back to you with this when you give them this requirement and say, sure, that's no problem. I'm just going to dump every log that I have to an event manager. Security focal, if they've had any security training, is not going to be very happy with that solution, right? It's not enough. You've got to monitor the logs. So no problem. Developer comes back and says, yeah, every Monday morning we have someone take a look at the logs. Johnny Boy over there does a great job. Well, he may as well be looking at binary code, right? There's too many logs. Most of them are probably not going to be relevant. It's going to be impossible for him to identify real problems. And certainly QRadar or your event manager isn't going to be able to identify offenses. So it's not really enough. You get the check mark. You're probably compliant. You're logging. You're monitoring, but you're not actually secure. So let's think of another way of going about this. Security focal knows that compliance isn't enough. It's not making the product secure. So he mandates that every component must send relevant, well-parsed, well-formatted security logs. Makes him very happy. QRadar can parse these, can generate offenses from these. Development components, developers, not so happy. You've got how many microservices, you've got how many applications, all developed in different ways. And and it's going to take them a long time to read this, long document on how they have to format everything that they send, and it's going to make them angry. They're going to become stomping at your door. Johnny Boy over there might come at you with an axe. Not a good situation. So it's a good solution from a security perspective, but it's going to slow down your development to a crawl. So when I started sort of taking on security role, it was about the same time that I joined the SRE team. And so I was able to, I tried to sort of apply concepts, merge the concepts together really. And the solution that we came up with, we sort of understood that all the developer components, both Java and Node, were using common appenders, so a log4j or log4js appender. So we could provide the components some basic configuration that ensured they were sending some relevant logs, and then we intercepted all those logs with a middleware for the Node apps and with Java Servlet filter for the Java components. We made it common, we made it easily configurable, and in the end we were left with something that was scalable. It was efficient. You could roll it out across as many components as you wanted within a couple of days, and very little effort. Your developers could implement this and make their application secure. So this made the new security guy, me, very happy. We were compliant, we were secure. It made all the developers happy too, because they could roll something out quickly. They didn't have to spend a whole lot of time. As a bonus, we were able to deliver both these things, or contribute both these things to the open source community. How much use they've gotten so far? Probably not much, but it's still a bonus in my opinion. So what are we talking about here? Secure engineering, an approach to security that involves SRE concepts, will buy you a maintainable velocity. And maintainable is sort of the most important word there. In today's environment, you really can't slow down your developers by stacking on security requirements to everything that they do, right? So if you're the turtle, your company's not going to survive. I think we can all agree there. Likewise, if your developers are sort of sprinting ahead, not without a care in the world, and then getting stopped and having to take a rest while security is implemented, also not such a good situation. So the best solution here is, to engineer your solutions. Most importantly, you need to take automation and common solutions as a default approach to every security requirement you try to comply with. In the end, you'll get consistency, you'll get efficiency, and you'll get sort of a tempered acceleration. You'll continue to accelerate, and you can build off of all the solutions that you've developed, and then your development velocity will snowball on itself, and it will get faster and faster, and you won't have to take breaks in between. So that is the 10, or I guess probably 7-minute version of my talk. So thank you very much.
And our final lightning talk of the day is Dale from Shopify.
Thank you. Hey, I'm Dale, and I work at Shopify on the production engineering team. And I just want to talk a little bit about burnout and just some of the things we've done to try to reduce just how common burnout is in our industry. Being responsible for incident response, being responsible for large production systems, and being on call is, I think, a huge part that contributes to the stress that results in burnout. So I just want to share a little bit about 3 things we've done, focusing in on the on-call aspect to help improve the health of our team. So first of all, how many people in the room are on call? I would expect it to be everyone. Yeah. And second question is, how many of you have been woken up or have had your evening disrupted in the past month? Past month? Okay. I was last woken up 9 days ago, so relatively recently for me as well. Cool. So talking to the right audience, I think all of you can play your part at improving the health where you work. So where were we? I just want to start going back a little bit in time. So where were we about 3 years ago? So 3 years ago, we had a pretty typical DevOps-focused operations team of 12. At that time, we were responsible for about 1,000 servers, getting up to 200 engineers total, and then dozens of services. And at that time, only about maybe 5 to 10 deploys a day. And on-call, the operations team that I was a part of was the primary on-call, responsible for responding to all incidents across the infrastructure, and we were supported by a single dev on-call rotation out of that group of 175 engineers. So I guess like what were the problems with this, right? So the three kind of biggest problems were just the heavy toil workload we had, right? So this is all about just the sheer amount of interrupt-driven work, repeatable manual tasks that were really taken away from any ability to work on long-term improvements and automation. This also ended up leading to some pretty serious incidents for us. So we get DDoS attacks regularly, and just not having the time to build the automation, to build the systems, just resulted in repeated incidents and repeated downtime. And this ultimately leads to lower job satisfaction when everything feels like it's broken, you feel powerless to do anything about it. That has a huge impact on your job satisfaction and therefore your job health. The other thing was just the breadth of knowledge. So we were kind of lying to ourselves. With that team of 12, we had some people that might know MySQL very well, but they were also responsible for something far away like Nginx, right? And so we had this kind of implicit on-call policy where if something happened to MySQL, you knew that one of the two database knowledgeable people were going to get paged, right? But the pager rotation showed that they were on call only once in every 6 weeks, when in reality they're on call every other week, right? So that's a serious problem that we had. And finally, we ended up with the rest of the engineering team, 175 people versus 12, ending up dumping some stuff on the team, and it wasn't really their fault. We couldn't keep up with the needs they had. So they would start forming new teams, one called the performance team, one called the future stack team, and they would build systems, but since they didn't have that on-call culture, they would hand it over to us for operationalizing it, and again, we would just have to handle even more breadth. So just going to quickly run through three things we did. So first of all, fix the team composition. So not going to spend too much time on this. Some great talks here. Cezar gave a brief overview of some of the things that go into this. Some great talks from some people at Facebook and Google over the years, and a lot about what this conference is about. But we really focused on getting a better ratio of systems folks to software engineers. Again, this was about helping us make progress towards that toil reduction and the long-term improvements around automation and resiliency. And then reducing the breadth of knowledge required, right? So making sure we had deep experts in each area who could also keep growing their expertise. And again, fix that implicit on-call and change it to an explicit rotation where they were supported by a full team of people that could take the time to actually understand the database storage layer to the depth we needed them to understand it. The second thing was just expecting more from that other group of people, that 175 people. So rather than have one on-call schedule there, move to service-specific schedules. And so rather than have them dump these services over to us for operations, really just enforcing that they need to own it. So at this point in time, we've now moved from those 2 on-call rotations to over 40 service-specific, area-specific on-call schedules. And I think some people often ask, what about devs who don't want to go on call, or it wasn't in their interview process, or wasn't in their job description? A lot of people here, you just hear them kind of laugh it off and say, well, like if you're not going to be, if you're not willing to stand behind your service, then like neither am I. And I think that's part of the conversation. But I think the second part, and I think this slide is really what I really want to focus on, is recognizing the burden of on call. And so we looked at, what could we do? So could we do pager pay? Could we do incident pay? What could we do? And at the end of the day, we tried to kind of come up with the simplest thing that really communicated that we cared about the health and well-being of our people. And so the first thing we did was we committed to 6-person on-call teams. And back then, we weren't actually able to do this. But again, this was kind of about setting that desired outcome for the future and showing people that we know that it's hard right now, but we're committed to making it better in the future. And then the second one, which kind of was our solution to, the concept of pager pay or time back, was for every week of on-call, and we work primarily on 1 week schedules, although we leave it up to our teams to kind of determine their own implementation of that. After a week of on-call, go ahead and take the following Friday off. And this is a really small thing for us, but it's really about, again, we're taking the time from people from their families, from their extracurricular activities, and this is a way to just let them let us show that we care and then give them some time back. And the final thing is a new thing that Leigh and her team rolled out recently is even with our bots, like can we make them a little bit more empathetic? So now, when you're incident manager on call and you have an incident lasting more than an hour, we put this into our global IMOC channel, and everybody else has noticed. You get some people that kind of come and help you out, and it's a lot easier to deal with that pressure when you feel kind of this level of support in your organization. And I should have said on that last thing, I'm not a labor lawyer or anything, so you might want to check if there's any kind of things that apply where maybe you have to do pager pay or something for overtime. So in terms of results, we saw a team that really had less burnout, reported feeling healthier, and really allowed us to kind of keep our momentum growing as the production engineering organization. And ultimately, what this really gave us time to was work on this feedback loop that we focus on. So detecting problems, correcting them with our incident response process, reflecting through RCAs and blameless postmortems, and then protecting through with focusing on how do we actually take the results of those RCAs and put them into practice so that we can kind of improve the resiliency of the system over time. So I really just want to encourage that, everyone here, whether you're a manager, team member, tech lead, it's your job to kind of raise the signal inside your organization and make people aware of the sacrifices people are making. Myself as a manager, I can sometimes at times lose sight of how noisy a certain rotation is or whatever, right? So it's really up to you to speak up. And I think we have a little bit of a hero culture problem as well, where people don't want to speak up and say, hey, this is really affecting my life, or I have these circumstances going on at home, and this is just making it really rough. If you say something, people in your organization are there to help, and if they're not, you should go find a job somewhere else. So with that, if you want to come talk about this or any other stuff that we're working on, come find us in the hall out there. Thanks.
So a big thank you to all of our Lightning Talk speakers. We now have a scheduled break out there in the foyer, and then the final talk of the session. So thanks, everyone.